three very simple rules that have gained huge traction all around the world with these conservation agriculture principles. And I think we're all familiar with the discussion around no-till, and we're going to talk about this now in a second, but it's just one piece of that puzzle, and it's like a three-legged stool. We have to also be thinking about soil cover. We have to also be thinking about plant diversity for that system to really function properly. So minimizing disturbance or any one of these is just one piece of the puzzle. It's about how they all work together is that key message. Soil covered, and then a separate maintaining living root. So we've teased out those two principles there, keeping the soil covered and maintaining a living root, and I'll talk about that in a second. And then of course the integration of livestock as that fifth also important principle. Away from our simplified landscapes, our monocultures, etc., and integrate more agrobiodiversity, have more diverse productive systems. And this is true if we're talking in-field or also farm-wide, making use of the field margins, the non-productive areas, the bioservice areas that can still also provide other ecosystem, ecological function, as well as then trying to optimize diversity in the productive areas. So that could be diversity through time, better rotations, novel cash crops, for example, making use of annuals if we're a perennial system, or if we're an annual system, trying to bring perennials in, or summer, winter species, warm, cool season plants, etc. This could be companion crops, intercrops, so again, trying to bring more diversity into the actual productive space, more diverse pastures, the multi-species pastures, the fertility layers, these kinds of things. And then some of that other ecological infrastructure around the edges, flower strips, biodiversity strips, bird seed strips, use of trees with cropping, trees with animals and grasses, silver culture, etc. So all of those various things which we can try to increase diversity.
Huge levels of nitrogen came onto the scene, really. That's what people did, that's what they farmed. They created biological processes, and building fertility was what they was all about. And what I really wanted to show you a little bit today was some of the links between the past and the present, to show you that actually that this regenerative process has been going on in the background for a long period of time.
Water out. So quite often we have to take those cover crops out before Christmas. But you can help sometimes by shallow lifting before putting the cover crop on, because you've opened the soil up, which allows you see in the rain.
These bacteria and other microbes are consuming these exudates, and in the case of bacteria, they are excreting byproducts from their consumption of exudates. And what kinds of things? Some very helpful things. Plant growth promoting hormones. So the botanical world really has farmed out something that it needs to the tiniest creatures on Earth so that the plants can grow. Is that stupid or is that smart? I think it's smart, because these microbes have a vast genome. All of these microbes in the plant microbiome. It's not, we talk about the proverbial tool in the toolbox. The microbiome is a whole hardware store, okay? Hardware stores as big as this Groundswell event site. That is what the plant is getting out of this. And so that's just bacteria. They're also producing compounds and molecules that stimulate the plant immune system. I like that. They are also, it's not just products, it's also intelligence. So compounds and molecules that are telling a plant, hey, pathogens are on the approach. It's time to gin up these other compounds and push those herbivores back. So this is what's going on. And as well, there's fetching fungi. So fungi are sort of like the miners and truckers down there beneath our feet. They can travel vast distances away from a plant, and they can fetch things. And here they are. This is their hyphae, these thread-like extensions on their body that go far, far away. And they're capturing things. Phosphorus, in particular, is a big one. Other things as well. And so It's this incessant, non-stop communication between the plant and the microbes, and even amongst the microbes themselves. Because they are doing trades and they are doing deals and they are figuring out how, in my tiny little one-cell body, am I going to thrive and survive to what, at their scale, is a vast, vast world. And when you're that tiny and that small, and you have a genomic repertoire like microbes do, you can't do a lot when you work with other microbes and when you work with a plant. So, what we know about the rhizosphere and the biological bazaar is that these are also some of the grandest symbiotic relationships that we know about on Earth. And for plant lovers, I'm one, we always marvel at, and we should, I'm not saying we should, we marvel at the coevolution between flower shape and pollinators. You get buff biomass on top of the ground. But look at that root system on the fertilizer diet. Excuse my French, but that sucks, okay? That's not the kind of root system that we really want. Hardly any exudates are gonna come out of that. And then you get these starving microbial populations down there in the rhizosphere, and it becomes a pretty bad place to live. You get a microbiome that's, just kind of half functioning. And so that means the plant growth promoting hormones, the plant stimulating the plant immune system, all of the intelligence that's coming up. The plant's not getting that. Contrast the soil health diet, which is rich in exudates, as well as plant organic matter, so-called residues, organic matter that's on top of the soil, because other kinds of soil life, because they will break that down, and eventually that gets down to the microbes. So this is the really sort of key thing if we think about the diet of plants and the key difference between fertilizer diet and a soil health diet.
Yeah. So what is regenerative ag? I think, we're living in a time where this movement, as like all movements, has started to get tribalized maybe, and co-opted by big ag, who maybe don't have holistic bottom lines. So I'm taking the liberty to define the baseline for regenerative ag as it must be carbon sequestration and soil building. If you're not building soil, you're in a degenerative situation. If you can't show you're building topsoil, then you can't really describe what you're doing as regenerative. Farms that build soil typically make a good living. Farms that damage their soil typically rely on subsidies. They don't work as businesses, right? And we're in England, where the average age of a farmer is what? 65 maybe? And they say to their kids, don't go into farming, go to the city, get a real job, because they've debased the soil, which is the only resource you actually manage as a farmer.
Where the most dense areas of root mass are, that's where you're going to have the most biological interactions. So one of the other tests is to look at where 80% of the roots are amassed. So if we've got a 16 centimetre depth, we're now looking for where about 80% go down. Sometimes it's helpful to break the block apart a bit, I'm a bit concerned it might crumble too much. Yeah, so this is good. There's some nice, different roots here, some finer ones and some thicker ones. And I think it's not one. What do you reckon? I don't know. What does Nicole reckon? What do you think? Nicole.
What does everyone reckon?
Yeah, what do people reckon?
But it crumbles well.
Yeah. So in terms of where 80% of the roots are amassed, it's somewhere in the top. I mean, this is sort of top 6-7 centimetres. So we're looking at kind of around 3 or 4. But I'd be really interested to hear what Nicole thinks about it. And we're looking for coatings of soil that are stuck to the roots. So rhizosheaths are basically where in the root zone the roots are exuding sugars and exudates and feeding the biology. So the microorganisms around the roots, that's where soil structure is starting to generate. So you should see coatings of soil around the roots. When you're doing these tests, it's the first thing that you might see start changing if you're changing the way you farm with a focus on soil health. So what we're looking for is whether the roots are white or if they have a slight covering of soil or if they're all covered. It can be quite, some of the coatings can be quite kind of fine, but you can see that, certainly on Abby's one, there are aggregates stuck in bigger particles, and on the smaller roots there are much finer coatings. But there are quite a lot lot of white roots here as well.
Can you remind us what the white roots indicate?
Well, less biological interaction. So if there isn't a soil coating, then you haven't got the biological interaction happening immediately around the roots.
Inside, if they're dark brown or black, then they're dead, right? So what we find is a lot of thatching in UK soils. Those roots are just sitting there dead. So you do want to break them apart and say, are you white? But, you know, like to see soil just stuck to it is really good. It's a good sign. That is your reactor for nitrogen fixation, free nitrogen fixation without the rhizobia.
No, really? It happens within aggregates, right? So in
Yeah,
an
it happens in the
anaerobic
aggregate.
environment inside an aggregate, the free living rhizobia in the aggregate can fix nitrogen, not just in the next test I do is looking for earthworms. It's very dry. I don't think we're going to see any. It's not really the right time of year. So spring and autumn, I'm going to fall down my own hole there. We then want to sort through the soil sample and count all the worms. And I tend to do the soil insect score at the same time. Would you recommend doing that?
Yes.
Nicole? Yeah. So you're looking to see if you can find any of the leather jackets or bugs or anything that might be eating your roots. It's interesting. Sometimes I get people responding and saying, oh, but isn't biodiversity in the system good in terms of it's good to see insects, but maybe not if they're eating your roots, and also everything in balance. You tend to see lots of one thing, like lots of leather jackets, so you're really looking for a balance of these things and not crossing a threshold. We've got some clover incoming.
What things doing and what are they telling me together? It doesn't mean you
To do is bricks testing. Has anyone used a refractometer before? Yeah. Great. They're quite fun. It's kind of like looking through a kaleidoscope. Without the colours, but you know that it's sugars. So if plants are photosynthesizing, they will have sugar in solution in their leaves, and that also means that they'll be sending a proportion of that sugar down their roots into the soil and feeding the soil biology. So what you would like is for the crop that you're growing, so your grasses or cereals, to be photosynthesizing more. If your undesirables or weeds, or I guess plants that you're not, you want to be creating the environment for the plants that you want to grow, not necessarily say for creeping thistle or other things. If they are photosynthesizing better, you know that the environment that you're providing is better for your undesirable plants. So we have the bricks barometer, where you do the bricks of each one and you see which one is doing better in terms of photosynthesis. So I've got two refractometers and also these sapphires as well, which and a garlic one.
Who wants to sample nettles?
I already got really stung when we were doing
me
the hole,
too.
so I'm not that keen about what they've got. So should we do it in there?
Completely the wrong way to go about fire cooking. You should be cooking the majority of things slowly, gently. Take your time with it, and that's where sort of flavour and pleasure lies, really. Rather
Absolutely.
than, steak is really the only thing I would be cooking very, very hot.
Which is a great point, because again, when we talk about steak, we'll touch on this later, we're talking about a muscle that has done very little work. So as a general rule of thumb, the lower the muscle to the ground, the more work it's done, so therefore the lower and slower you cook it. So gentle heat, give it some time. The higher up you go, when you get to the back, when you get to the steak muscles, that muscle's done less work, so you can cook it hard and fast. But one thing that